All right, so this function, the binomPDF function, is going to be your friend on the graphing calculator. It's really going to help you, and it stands for the binomial probability density function, and it looks something like this. You might also see it written like this, but those are the same thing, right? We've got um, n choose r also written this way, n choose r. And we'll go over what each of these things mean. First of all, n is the number of trials. R is the number of successes. That just means the number of things you're looking for. So you're flipping a coin. You want to see out of 100 flips, let's say n would then be 100. And you want to know how many times can you expect to get 20 heads. Well, R would be 20. It's the number of things you're looking for. P is the probability of that thing happening, and P will always be to the R power. And Q is the probability of failure. So essentially what you're not looking for. So if you're looking for 20 heads, you're looking for 80 tails. And the probability of getting a tails would be Q, and n minus r is the number of tails. So if there are 100 flips, that's n. 20 is the number of heads. So therefore there would be 100 minus 20, right, heads, and that's 80 tails. 20 heads, 80 tails, because r plus n minus r is just n, because r and negative r cancel out, and n is the number of trials. It all works out. So we'll go through this problem right now. Imagine you flip a coin 100 times. What is the probability that there will be exactly 40 heads? Now, if you see this phrase, exactly 40 heads, that's when you're going to be using the binomial PDF function. And on a graphing calculator, what that would look like, let me just quit out of this real quick. On the graphing calculator, you could just power through this. You could type in this case, 100, and then go to math, probability, NCR, that's the combinations function right there. And then R is 40. 100 choose 40. Big number. And then you're going to multiply by that, but the probability of getting a heads for 40 times. So times that answer times 0.5 to the 40th power. Let's try to do this all at once. And then that times 0.5 to the n minus r, so 100 minus 40, or 60. Right, there's 60 tails if there are 40 heads. And we get about 0.0108, so about 1%, 1.1%. Now, that's what it looks like going through it on a calculator, but we can do that all quickly on a calculator by hitting second vars for variables. We get distribution functions. So we're not going to the normal PDF or normal CDF, but the binomial distribution. So let's go to that. You should see it down here. Always forget what number it is. There it is. It is choice A. Hit enter. And you can usually get a menu like this. If you don't get a menu and you just get parentheses, look at the order here. This is the order of the things you're entering. So you always enter the number of trials first. So it's 100. So even if you don't have this screen, if you have parentheses, it'll just say binom PDF with a bracket. You could first type in 100. Then you would type in comma if you don't have this screen. Comma button's right here above the 7. That's where the comma is. But I'm just going to hit enter. P, the next number you type, whether you have the screen or not, whatever the second number is that you type is the probability of success. You type 0.5 and either comma or here in this case enter. X value, now X is we didn't use X as a variable, right? But X is the number of times you're looking for success. So in this case, it's 40. We're looking for 40 successes, and then the calculator can infer the rest because it knows that Q is always the complement of P. So if P is 0.5, the complement is always 1 minus P, and so it's 1 minus 0.5, Q is 0.5, and then it knows that the exponent for Q is just 100 minus 40 or 60. Go to hit enter, and we'll get the same number. You see that? Nice and easy. So you see right here how it says binom PDF with parentheses 100 comma 0.5 and then comma 40. Let me see if I can grab that. Right, you might have that. You might have the other screen. this is the same thing. It's the number of trials, probability, number of successes. And that's the binompdf function. What if we change the question, though? Oh, I plugged it in here. Here, 140, right? This is what we just plugged in. You could power through this, right? That's what we just did. But what if I ask you this question? The probability that there will be at most 40 heads, and that could be a nightmare situation because you have to do the binom PDF for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 40. It's a nightmare. Fortunately, we have a different function. Just this distribution function is called the binomcdf, and it's a cumulative distribution function. It basically adds up everything up until the number you're looking at. So it's perfect for at most questions. The function itself looks like this. The probability, R, is the number of successes. So successes less than or equal up to some value k. In this case, k is 40. This is summation notation. So it depends on where you're at in your math class. You might need to know this, but you're adding up all the different binom PDFs from 0 all the way up to k, whatever that k value is. It would be 40, and here's that binom PDF. So this just means that this summation just means add up all the different binom PDFs from 0, go from 0 up to k. In our case, 0 to 40. So from 0 heads all the way up to 40. You'll actually do all the additions for you. Isn't that wonderful? So we could do, clear this off, second, bars, and then we go down, 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 down. It's probably going to be the letter B, but I don't want to risk it. Keep going, going, and boom. There it is, letter B. Binomcdf, same idea, number of trials, we've got 100. The value a probability that we're looking for is 0.5, and the number of successes is up to 40 this time. And hit enter. And it's about 2.8%, right? So actually not that much higher there. So this is the idea of the binomcdf function. The probability that would be at least, or at most, 40 heads. And I guess that makes a little bit of sense because you would expect for there to be maybe more than 40 heads, right? Now what about if we said at least 40 heads? Well, we can still use our binomial cumulative distribution function, except we're going to take the complement. And the way we're going to do this is here we have the calculation for at most 40, but now we need at least 40. So it's kind of like the other side of this, except we're not going to do, well, let me just say first that we do the complement. So we do 1 minus the binomial distribution, a cumulative distribution function. But I think I can do it this way. Let me do 1 minus second variables, go in choice B. And here, this time, we're going to look at not 40, but 39. Because what this function will do, it'll give you all the probabilities of getting heads up to 39 heads. But at least includes 40. So it's the other side of that. At least would be 40 all the way up to 100. So 1 minus the probability of getting up to 39, at most 39, is equal to getting at least 40. So I'm going to hit enter here. And I'm going to get a really high probability because here getting at least 40 heads is very likely, close to half. You might be surprised again about the at most 40, but it's surprisingly low chance that would happen. I said surprise a bunch there. Well, maybe you expect, well, 40 seems pretty likely, but it's much more likely that you get more than 40, and that's what we're seeing here. So at least 40 is far more likely. All right, hope that helped.